to the session.
Hello, everyone. Thanks for joining. So the topic I present here is called Microfrontends with Blazor. Welcome to the party. So you may have heard about microfrontends. You may not have heard about them. I'm here to give you an introduction, show you how to use them with Blazor, show you what techniques you can use, why you maybe already use them, and why it may be a good thing to, well, think of them in the future. Before we jump right into the topic, let's just a few words about me. My name is Florian Rappel. I'm from Munich, Germany. I'm a solution architect at a smaller company called Smartpiot. We are doing digital transformation projects and also consulting in the area of software architecture, building platforms. And I'm also heavily contributed to open source projects. You can reach out to me on Twitter, find my profile on GitHub, or just in general, find the company I'm working on, for instance, on LinkedIn. I'm a Microsoft MVP for development technologies, and in the recent, let's say, 4 to 5 years, I spent most of my time dealing with this architecture pattern of microfrontends. I'm currently writing a book there. It will be released hopefully in 4 or 5 months. And just follow me on Twitter if you want to have updates on this, have general questions on microfrontends, or just want to have, let's say, an exchange on technical subjects. Let's go right into the topic. Let's start with a motivational example. What I want to present you here is, let's say, a more or less standard system architecture example that you find, well, plenty of these days. Quite often people follow microservices. They don't know why. Quite often it makes sense. Sometimes it doesn't make sense. But in general, a structure may look like this. You may have some user-facing services. So in this example, service A, B, C. And then there may be some hidden layers, right? Some service X, Y. These are helper services. They're not user-facing. They're more or less internal. And then there is, let's say, a communication going on between these services, right? So service A may rely on some data of service X, and service B relies on more, and maybe there's an exchange of service X and Y. So that being said, why are we, let's say, investing in this complexity? What benefits do we get? What are the properties of microservices? Well, as you know, you usually should scope your microservices around business capabilities. That gives you the capability of really placing autonomous teams, which are usually then the main experts around these business capabilities. And well, developing on your own is quite efficient, as you know. You don't need to align. You can just make the changes. You may even, well, select your own technology stack. So all in all, you get this development lifecycle that now an autonomous team controls. You should be rather loosely coupled and you are technology independent, which may be a good or a bad thing, depending on how it's driven, right? In general, it's a good thing because that allows you to choose the best technology for the job. But if you just do it, let's say, for the sake of using new technologies, then at the end you end up with a patchwork backend, and that's not a good thing to maintain, right? But looking at the front end, we are seeing that this is usually then still done in a kind of monolithic architecture. And there are reasons for that too, right? So you get the best user experience just out of the box. This is fairly integrated and totally consistent, right? You always use the same elements, you make them reusable. It's quite nice. But there are drawbacks developed by larger teams, and you got then, of course, very long deployment cycles, which means any change may break something in your large code base, and so you need to test it more extensively. Since it's user-facing anyway, you want to be quite sure that this thing just works and that there is no regression. But still, we know that there are some really large applications outside. Let's take a look at, for instance, what we know as the Azure portal, all right? Yes, it's a slightly older version, but it doesn't matter since these technical principles didn't change. So what you know of the Azure portal is that, well, if they release a new kind of service, suddenly there is a new blade in there, right? If you got some preview rights, suddenly you see this kind of service there with some admin functionality. And all of that is possible because, well, they already use something like a micro front-end technique here, and they can compose that together more or less on the fly. They can dynamically assemble and stitch that together depending on your privileges, your user account, and your company settings, for instance. Now, of course, you may say, okay, well, that's Microsoft. They got a huge engineering team behind that, and so of course they can do that, right? But with limited resources, how can you achieve that? Well, just one example, a project that I was also involved in, a German company. So there the team was, well, I would say some magnitudes smaller than the Azure portal, but still a very nice portal experience was here created. So all the functionality that you see here was essentially developed autonomously. And at the end of the day, if you are a user that, for instance, can use something like a software download, you get this functionality. You get a menu item for this. You get now this area. And yeah, in this area, by the way, there may be Blazor running just for this download experience then in there. In this case, we didn't use Blazor because at that time it wasn't there. Yeah, that's one of the possibilities that just arises if you are able to, let's say, stitch together your front end on the fly. Now, the only question is, how can you do that, right? Well, there is the microfrontend architecture, as you may guess. And this is pretty much, let's say, in a pure form, looking like the following slide. What you could start with is you still have your backend here in a simplified view, service A, B, C, D. And now you place on top for each service a corresponding micro frontend, right? So you may say, okay, you got now micro frontend A, B, C, D. Now, the simplest way to achieve this is instead of serving back JSON, for instance, from your services, serving back HTML, maybe only HTML, maybe if the right accept header is matched, maybe if a corresponding URL was hit. Nevertheless, that's more or less the easiest way. But once you reach this point and you serve from your microservices just HTML, the question that comes up, of course, is how do they now come together as one, right? Because giving an end user just, in this case, 4 URLs is not what you want. And sometimes you want to show joint information. Let's say service A gives you some user information. Service B gives you some permission information. You don't want to go into a web page of service A, just see all the users, go into a web page of service B, seeing all the permissions, and then having to connect these dots yourself. You want to see that in one UI, right? You want to see the users and there are the permissions for these users. So how can you now join this information? How can you go away from this pure view of micro frontends and leverage then really some architecture techniques to bring together these independent pieces? Well, let's see how we propose to change this. What we could do is we just place all these micro frontends around or inside a, let's say, what we call application shell. So this is, let's say, just an index HTML file. It's one position where they all would come together. And now, instead of having independent web services, what we could do is just publish some modules, some static files maybe, could be also still on web servers being rendered. And we could just call them modules now because they live inside this application shell. So all in all, this is more or less like a plugin pattern. But wait for it. There's a little bit more, of course, because usually plugins, they're very well known. You need to have a very strong defined interface. And yeah, you need to have them already maybe on the disk. They can't just change dynamically. Yeah, not without effort, of course. And a couple more things, right? So usually they're very, very much restricted to what you dictate these plugins can do. But in this case, all these modules should have full document object model access, and they should be able to come with their own packages, their own dependencies, and they should be able of, yeah, driving the application, or at least co-driving them. To help them do that, you may place some more things in your application shell. You may place, for instance, already shared libraries. For Blazor, for instance, that means that you could share, well, the core .NET runtime. So MS Core Lib, for instance, you could share there. We come to the topic later when we say, okay, what can we actually do? What can we share? Because there's a lot of tree shaking and optimizations with Blazor, and that may not come into, let's say, or for our benefits. So we will see what we can do about it. Now, the other thing is we could assist the front ends with a pattern library. So that just brings components that you want to use all the time to achieve consistency. Right, and then of course the application shell is mostly concerned with what we could call core and common capabilities. So that could include, for instance, authentication and authorization, but it could also include how do you, let's say, or to which backends you can communicate, and could also have a common permission model and all these things. So whatever you say is a cross-cutting concern, that may be a good place to, or a good functionality to place in the app shell. Right, so this is where we stand. This is how we could do it, let's say, on paper. That also fits in nicely to the evolution we see over web pages in general, right? So if we start looking in the past, we always started with this monolith. I mean, since the early days of just serving some static files, somewhere up to introduction of CGI and then PHP and so on, it was always this single system, right? Front end, back end fused. We always just spit out some HTML, all the database access, everything was in there. The standard 3-tier architecture, all implemented in one system. Then, of course, we know there was a separation going on, and we said, okay, now let's have the API a little bit more flexible, such that we could use multiple clients. Now, that was born out of, well, the reuse with mobile devices. There we had a different kind of application. It was usually an app, and we wanted to use the same API because at the end of the day, it was the same data. That also brought in more advantages. So suddenly we could open up our API, others could consume it. Yeah, brought us the challenge of API keys. But then again, problems were arising, right? This monolith was hard to control, and so we split that up and we introduced microservices. Now, usually they are hidden behind a gateway, but nevertheless, I mean, we had now the services there, and we could still say, oh, yeah, we provide an API key now for a specific service or at the gateway level and solve this issue. We still remain flexible. And now with the introduction of microfrontends, of course, that whole thing is mirrored also on the front end. So now we have this application shell taking the role of the gateway, and that pretty much is responsible for fusing together, composing all the different front-end fragments. And I think that's a nice evolution there. Again, if it doesn't mean that you need to use this, and that's a very important point. There is nothing simpler and more efficient than a monolith, at least for smaller projects, right? And then when the project grows, I mean, it's really about how well was the monolith developed in the first place. So if that has a good architecture, was developed in a sound way, then splitting it up like in this front and back end separation, or even, well, I don't know, extracting microservices or microfrontends out of it is actually quite simple. Of course, it's some effort, but it is actually not that difficult to do. If that whole thing was fully entangled and, well, spaghetti everywhere, yeah, then it's of course hard as hell. But then you would need to do something anyway about this application, in my opinion. And there's a full refactoring anyway incoming. So yeah, you can think about if you want them to remain on the old system or go to something new. That being said, yeah, what are we talking about? Let's look what we can do in Blazor with, well, composing together microfrontends or fragments of frontends. Let's call it like that. So let's see what our options are to actually get some of these bricks together. And let's start with the most straightforward approach, and you may have used that already. That's a usage of, well, libraries, just usually packaged up as NuGet packages. Doesn't matter, but yeah, just using DLLs. That approach is actually as old as, well, maybe even ASP.NET itself, but certainly as old as ASP.NET MVC, especially with the introduction of areas, if you know that. So there you could already place front-end fragments all in a dedicated DLL, declare it an area, get that in your main application, and then even place, let's say, a reflection mechanism on top to dynamically on the application startup, for instance, look for such front-end fragment libraries. Now, if you do that, what advantage do you get? Let's see. So first, we use the picture from before and again. So we have an application shell. That's now a Blazor WebAssembly application. And we got some used libs and even a design library for a kind of a pattern library. So there could be the Blazor Bootstrap Mondo, for instance. And now our modules are essentially these libraries. So we bring in a library A or B or others, and together they form what is our application, right? So before we look at the demo, what are the advantages of this approach? Well, it is definitely quite nice to stay always in this flow. We will always stay in Visual Studio. We will always use the tools of Visual Studio, and yeah, together with C#, that's used all the way. That's a very, very nice experience. On the downside, we have some drawbacks too, of course. So we require recompilation when any of these NuGet packages changed. Yes, there are ways around this. Then we may have a service that unpacks already a NuGet package, and we have the DLLs somewhere. But yeah, honestly, especially if we're thinking already in the future, and this approach may be something for the future, recompilation will be a thing here. No cross-framework support, at least out of the box, and that means we will only have Blazor. I mean, that's what we want, maybe. But if some team wants to develop, I don't know, a component in React, that's not supported out of the box. And we need to have the full evaluation before we start. I mean, that's the Blazor mode, right? So your application, your app shell starts, and Blazor needs to be transported fully in. That means you need to get the WASM in there, which is able to handle the DLLs, and then the DLLs need also to be transported in. And only when they are fully loaded, the application can fully start. That's a lot of let's say, bandwidth needed in order to get this thing running. The user experience with these things are usually, well, once it's running, they're great. There's no difference. But, well, the loading time is definitely a drawback. All right, now let's look at a demo. Right, now what I want to show you here is a simple approach. Instead of NuGet packages, I just used libraries here, but would be pretty much the same. You get always then just references in your project, and in here it Blazor library A and Blazor library B. So how they look is fairly simple. They bring a navigation item, just saying, for instance, comp A, or for the lib B, we have comp B, right? And then we have a page component. But this is it. I mean, there is not more in there. Now, the way that we integrate it is fairly simple. We have in our startup just a configuration, and we just to our app builder add these libraries. These are actually extension methods, and that's about it, right? So we add our app component. That's the standard way that you know, and then we just add these libraries. That doesn't do much. It just goes over the assembly, adds them to our assembly collection, and then we find if we have more menu items. So we already have, let's say, yeah, some defined way how we would register menu items, and it's going via reflection, as you see. And by convention, we just say, is there nav item in there? This is nothing that I would recommend in production. I would use attributes actually, but for simplicity, let's stick with this approach. We put it in a menu items container, and that's it. Now, how are these two things coming together? We got the pages and we got the menu items. Or pages is rather simple, right? Because that's already offered by the Blazor router. We just say, okay, additional assemblies, and we're good. And regarding the menu item, well, we need to look in our design, right? So what we in the end come up with is a nav menu as defined here that has then a flexible section in there. So here we render fragments. And what we do is we go over all the menu items, and yeah, we just open and close these components. So there's no children here, there's no attributes that we need to write out. We just say, oh, these are just nav items that we dynamically got, and this is it, pretty much, right? And the result then looks like this. Let's try to start it. See, make this a little bit larger, and here we got our menu with comp A and comp B, right? They were not written in the code, so they're dynamically in there from the libraries. And this is page A, right? It has comp A, and comp B has also its own URL, still sits in there, and they are nicely together with, that's the more or less standard Blazor application. So as you can see, dynamically, we brought in now these components now for menu item and for the pages, and they just work fine. So very simple mechanism for these libraries to create. You can just select a Blazor component library, and that's it, right? So Blazor gives you already everything that you may want for doing that. So awesome approach, right? Not much to say here. Now, going a step further, we've seen that one of the disadvantages was we are fully captured in this Blazor world. That's also an advantage. So there are always two sides of the coin. But what if we want to have this openness? What if we want to use actually other frameworks like React or Angular? Who knows, right? Well, we need to combine that with JavaScript. So we need to come up with an approach where JavaScript may also play a more crucial role, and we do a little bit of JS interop too. In the end, that would allow us to recombine freely. So for instance, we could have a full React application and suddenly one component is Blazor, could be the other way around. We could have an application where there's an Angular component that uses a Blazor component that uses a React component. So things like that are also possible. We can freely do that with any framework. And since we bring in these Blazor components potentially at a later point in time, so you go to some sub-page of your single page application now that has a Blazor component, we should be able to only do that on lazy loading, meaning that the application startup will be as fast as possible. And only when we require Blazor, we will need to load the Blazor, but then the rest also already rendered fine. The drawbacks, of course, that the complexity skyrockets, right? So it's difficult to publish this thing correctly. There are multiple places now you can do distributed publish or release jobs, and that never brings in more simplicity to a project. And of course, we can't just stay in the C# flow. So we need to have JS parts that do more or less the orchestration in this case, and we need to have C# parts now for doing Blazor or driving this interoperability together with JavaScript. And all in all, if you ever touch that JS interoperability with Blazor, I mean, it's very cool that works, and how it works is also quite well engineered in my opinion, but it's also not easy. There are certain pitfalls that you can easily be trapped in, and so getting this system right is definitely more complex than what we've seen earlier. I mean, that, as you saw, for instance, the routing, that's a no-brainer. That's just done by Blazor directly, just adding one attribute, and you're done. All right. So that being said, let's look into different challenges of the second pattern with JavaScript. Let's tackle each one of them, and then let's see how they may come together combined to form a microfrontend solution. All right. So challenge number one is routing. Why is that a challenge? Well, Blazor, as you know, Blazor doesn't like to be, let's say, well, not alone. So Blazor is a typical singleton framework, what I would call it, meaning that it tries to capture the full document object model. It tries to do everything. It tries to do for full routing. There can't be another single page application framework when you run Blazor. That is a challenge, and it's a major pain actually to get there for Blazor working in these microfrontend solutions. And let's see how that manifests. So let's use this sample here. So what we have here is, our standard router, right? And we have the found part where we say we found something, and then we have the not found part where we say, okay, what should we present if there is nothing? And these two sections are actually required. So there is no way that you could just remove this and it still works. But what you can do is that you can remove this part here, and I will show you in a second why that matters. First, let me just run the demo, and then I'll explain what we see and why we see it. And then let's see potential strategies here. So starting is always a good thing. And so we got here 5 points. So the first 3, these are all coming from Blazor. But then we got 2 new URLs or new 2 menu items called foo and bar. And as you can see, or hopefully can see at the bottom of the screen, this will lead to /foo, and the other one will lead to /bar. So let's try to follow the link for /foo. I hope you saw that because it was quite fast, but there was something about loading and then some page from React, something like that. Let's click on bar and the same. So we got here a message that we are on some page. And actually what these 2 URLs should correspond to is, well, a page from React. And I want to show you that before we look again at the sample. So here we got our sample page, and we got actually 2 microfrontend or 2 single page applications running in there. So one is here, the Blazor app, and it always has the loading. That's why we saw loading ... on top. And the other one is the root of a React component or a React application. And we call that React app. Now, the ready code is in here. Well, I don't want to go over this minified thing. If you would look at it, let's say in the real source view, we would see that it's a standard React router, and that just registers these 2 routes, foo and bar, and that's it. But as you saw, that doesn't work so nicely, right? Because always Blazor is then showing the not found screen. The other thing to note is that if Blazor detects a navigation, and that's in the nav item, right, that does go outside its own, let's say, jurisdiction. And here the jurisdiction is defined by the pages that are registered via reflection. Then Blazor will just do a top-level navigation, meaning you leave the single-page navigation mode. You're not just changing the URL, for instance, but you're really reloading the page, which is definitely not what we want. But against that, at least on this high level, we can't do something. For this to fix, we need more. We need to go into actually the JavaScript bridge from Blazor, and we need to override the router there. There is no other way. There's one other way, of course. We could have an anchor tag here with a custom, let's say, behavior defined also in JavaScript that uses the browser's history API. But let's at the moment skip this. Let's just see how we could solve it, let's say more or less immediately. And the answer is, let's just remove a few on the not found page. Because then not found will not render anything on Blazor, which means Blazor will stay empty, Blazor will stay in the background in these cases, and then suddenly we're on the full page of React. The loading still was there and disappeared, so this is not a good experience. We could work against that by not having this loading ... shown in the loading case, and maybe having something else unless when Blazor is loading, something like a top-level router that says if I'm neither on React nor on let's say anything else. So it's definitely Blazor. We showed up the loading and then hide it. Okay, so foo and bar are then working, even though again these are full-page transitions, and that's not what we want. But again, what we need to do is just remove the, let's say, few or not found and handle that differently. So that was challenge 1. Again, just showing here a glimpse. Challenge 2 is a little bit, let's say, trickier to see, but it's what I would call DOM projection. Now, Blazor doesn't bring a way out of the box to say, I want something what is called in React a portal. And a portal is actually a very nice way of saying, yeah, I got this part of my, in the React case, React tree, but I don't want to have it below the same DOM tree. And maybe I want to have this part of my React render tree, I want to show it somewhere else. And the reason why in the Blazor case this is interesting is because, yeah, we only got one Blazor render tree. But what if we want on, let's say, several positions in our page to show Blazor components, right? So there are only two ways then. The first way is, well, Blazor drives the whole application. So there is no need to distribute anything because, yeah, the whole application is just Blazor. But if you're thinking about this micro-frontend case, well, the whole application is not Blazor, right? And Blazor is not in the driver's seat anymore. But still, we want to have Blazor here, there, and there. So how will we do it? We still have this one tree. And what if we could take parts of this one tree and say, oh, this part goes, by the way, here, this part goes here, and the last part goes into the final position. And that's what I would call a DOM projection. So we want to project this subtree of Blazor somewhere else. Let's see how we could do that in a very simple way. Here we got, again, the standard page. We got a counter page, great. And it's the standard counter example. So there's nothing here to worry about, except I inserted one div, and that div is special because I gave it the ID projection source. So that's the thing I want to project somewhere. Now, where do I want to project it? Well, let's have a look at the index HTML. I want to project it to projection target. Now that could be dynamic somewhere, but for this example, we always say this is where we want to place it. And I didn't want to introduce another button or JS interop, so I just wrote a function that we will call from the browser's console, and I called this function project. And what I want to demonstrate with this is that I can just take the projection source and place it in the projection target, and this will just work. And it's a little bit like magic, but yeah, let's see that. And then I'll discuss why it works, why one needs to be careful when doing that. So it's not just an everyday trick that we should always use. One needs to be very careful with it. And yeah, that's the counter. So let's start counting, I would say. Great. And now let's use the project function. Counter disappeared. Well, it's now here. That's because this is where our projection target sits, right? So we could also say, of course, now our projection target gets a nice new, I don't know, styling. like a border, maybe 2px, solid red, maybe dashed red, right? So we got now this in here. Maybe we have a little bit of a margin, 1 EM, and a padding of 1 EM. So this is now where we project to, right? So this is our projection target. And now you say, oh, we just brought it over. Blazor is now broken. No, it's not. I click this, I count, right? So I can still click here and I'm counting. Great. How does this behave if I just swap? I mean, this thing is now projected away, no longer controlled by Blazor in this case. So it just remains there and I get a new counter. If I click that, well, it's not bound to this anymore. So new counter, right? I can now project this one into the target 2. Now we got 2 in there, 19, 7, and still counting here. Now that works because Blazor doesn't care about all the specific positions. Blazor just cares on the top level and it says, oh, then I got this DOM element, I just saved this reference. So as long as we keep the same reference, it doesn't care that it now shifted in document object model. It would care though if we have an update that is, let's say, impacting the old position, because then suddenly there's an element missing and it says, oh, whoa, I wanted my model. I now had just to move something next to it, but now this one thing is not there, so I just crash. So this is why it's a fragile mechanism, and it should be very much controlled how you do the projection and what you can do with the projection. But that you can do it, and that you can do it quite easily, is quite cool, because that allows you really to have these micro components that are just in one Blazor tree, but they're all Blazor components and you just use them in a non-Blazor application at some positions. It's quite a powerful mechanism. And as I hopefully demonstrated here, this would also offer a very nice way of getting this routing to work, because we could use something like React to do the whole routing. Blazor is mounted in what I would call primarily a headless or lookless application, and all the components that would actually, let's say, bring some design, etc., they are all then projected into, for instance, a page that's mounted from React's router, and so that would just work actually. And this is how you can, let's say, starting with JavaScript, build an application microfrontend solution with Blazor, just working with all other frameworks. So in this case, this projection thing is a very elemental thing. You need that to circumvent the singleton character of Blazor. Right. Now, next challenge, dynamic registration. Now, what is all that good for if we always need to know hard-coded what kind of Blazor components are there? So example is that we have, again, this non-Blazor application where we say here a component, here component, here component, right? Now this, where what component is, that may change very dynamically. And the question is now, do you need always to recompile a Blazor application when, I don't know, a new component should come in here for Blazor, or when a new component is demanded on the JavaScript side? And I don't think that this makes any sense. So you need to be able to dynamically do that. In order to do that, let's look at an example. The code here is a little bit more complicated, but at the end of the day, it's just there, of course, for demonstration purposes. So all that we do here in this, here a little bit sidelined counter component is that we have a logic of registering or activating or deactivating components. So what we will do is, when we hit 1, and we start, by the way, at 0, we will register the two components, first and second. But since we start at 0, we already went one time through the switch, and at the 0 case, we will deactivate one component second and activate one component first. And what that means is essentially that nothing will happen in the first place. This should just show that unless there is something registered, activate and deactivate will not do anything, and they will not crash the application either. So you can just activate whatever you want to. You can also deactivate whatever you want to, and that would just work, even though there is nothing there. But, and that's the case number one already, if there is something like the first component, we can activate it. So we can create instances of that. And we will go on with this logic. We will activate firsts, and we will activate seconds, and we will also deactivate seconds and get more firsts in there. So at the end of the day, everything will be a first, and we will not have a lot of instances of whatever this first thing is. Actually, it will display first component, so it's a very trivial thing. And second will just display second component. So they're both not very spectacular, but they are dynamically registered, and that's the crucial part here. Now, in order to use that, we will use a special construct. We will call it placeholder here. It's a yeah, as the name suggests, a placeholder where we actually will render all the activated components, so the instances of these components. Right, so we do that just in a loop, and yeah, we are listening to a changed event on a special container that we call activation, and that one, yeah, is in this component activation service. Right. Yeah, I would say let's just look at this example to first see it, and then maybe have a second look at the code. Because I know the code in this example is not as straightforward, but it should give the right illustration for it. So we click, and again, on the first click, nothing happens. But on the second, we should see a first component, then a second component. Then we remove the second component and add another first component. Then another first component, then a second component. Then we remove the second component and another first. So as said, we get more and more first components in here. That just is growing, and yeah, we're just registering these instances, and they're just in there naturally, right? And they stay there because we registered them. So this just works. And again, we in our placeholder here never mentioned that there is something like a first or a second explicitly. Instead, they just have been added dynamically using now this click event. But in general, you could imagine that these registrations here, they are done, let's say, what we did before and with the menu item in our NuGet case. So we just via reflection read them out, for instance, using an attribute, and then we just register them in some container. And at this point, somewhere in our code, we may activate them. So activating could mean, oh, we've seen now a fragment is needed at this position. So we activate in this position, this fragment, and maybe we use the projection mechanism we introduced before, and right. So that's how you would use these dynamic registrations. And they are very important in this microfrontend case because you won't use the loose coupling. Otherwise, you always need to rebuild. And you get strong coupling between the microfrontends, and that's nothing you want, because then you could go back to a monolith in any case. Shared components. Now, pretty much what we were accumulating to is that you can also use other components. Now, we always talk about the case of using Blazor in JavaScript, and all these things are needed for that. But what about using now other JavaScript things, like, for instance, React in Blazor, right? And using that very nicely. So let's see at the code. The counter is now here modified a bit. Instead of having all the counter in there, what we see is we use an external component, and we give it a component name. So here, the external component with the name title should be shown. And here, the external component with the name counter should be shown. So now the question is, what are these components? Now, first, let's have a look how the demo looks like. And then let's have a look how these components are defined and brought in. These are both React components. And you see, it doesn't look as nice as before, and they are not styled. So the title is counter example, and the counter is the 0 and the increment button. And if we click that, well, it just increments, right? If you go in again, it resetted. So exactly as in the Blazor example, just with a inferior design. So how is this external component defined? Quite simple. We have a JS interop going on here, but all that we do is that we say we have a div and we give it a random ID. So in this case, we call it react minus and then a new GUID. And that's about it. Now we have a container where we can place in any kind of external framework component. And all that we need to do is we invoke a special function called render react, and we give it now this desired component name and the ID to do the protection as arguments. And then we are done, right? All that is left is to see the React code. This is how we define the window render react. That's called from the JS interop. And here we get our two arguments, component name, counter ID, the container ID. We have the component selected dynamically from, well, all the available components. And then there is the render function from React, that's all. And as container, we get the element by ID here. All right, so having that, let's have a look at how the components look like. So we have two components. Let me just open them. We have the title. That's the title. So it's just an H1. That's it. Like more or less the simplest React component you may imagine. Just function returning that H1. And in the counter case, it's a more complicated React example. If you know React, we're using the hooks to establish a state on this one, and then we just print out the count and we can set it dynamically using this on-click handler here. And that's all. So we brought in these two things, named them appropriately like counter and title, and that's how we can access them in our counter here in Blazor. And suddenly that just works. We have that abstracted away in its own component, and we are done. Right. Cool. Then next challenge is lazy loading. Yeah, that is now solved within Blazor. So with the .NET 5 update, they released something really cool. You can now do that. Still, I want to show you maybe what I would call an older way of doing that, or that it just works. I don't want to go over the code in this example, but as already mentioned, lazy loading is a really important aspect, especially if your Blazor application grows and you use these NuGet packages, for instance. You may want to have a mechanism to say, oh yeah, there is some page, and it, by the way, is driven from another library, but don't load that library in the beginning. Don't spend your time on this. Right, so now I think going to the counter, that's now from a different library, and if you can see that here, and I make it a little larger, is that once I clicked on this page, we got a request and we got the DLL in here and the debug information. And if we do that again, nothing is loaded because it's already there. I mean, it's lazy loaded, meaning it's just loaded once, and it's already loaded when you need it. Right. So great. And so if you now have all these pieces together, then I think you're on a good track to having microfrontends implemented. And just to finish this with one, let's say, what I would call reference implementation that we are working on is what we would call a framework for modular distributed microfrontends, and we named it Pyral. So code is open source. You can check out documentation. It's not a start with Blazor, end with Blazor microfrontend, but it's, let's say, a generic JavaScript solution where you can also bring in, exactly with the techniques that I mentioned here, other Blazor driven applications as microfrontends. So just to briefly look at how you could now such an architecture as it's done with this framework. You have your app shell, we call it Pirate instance. You have your microfrontends, we call them just pilots. They're just static files or can be also hosted somewhere. And then you have different aspects, like someone who is creating the pilots, a module developer uses a special command line tool written in Node.js. And in order to be fully dynamic, you need an ingredient that we haven't discussed so much beforehand, but you need to have some kind of a feed, because otherwise you always need to recompile, of course, and ship that somewhere. But if you want to, let's say, just keep your app shell as is and want to grow in your microfrontends, you need some kind of a backend service for it, or at least some static file that you update on the fly. So here we call it a feed service, and that may have other features in there too. So features like a feature flag evaluation, such that you can dynamically decide what microfrontends are, let's say, suitable for the current user. And then again, we are at this position where we say loose coupling is a good thing, because if they are strongly coupled, you can't just blindly do feature flags, because you may have these interdependencies. So microfrontend A requires B, and if you, for some reason, don't deliver B, then the whole application breaks. That's not a good thing, right? Okay, so having that, you can just put it on static storage, like Azure static website, and then you may have all your infrastructure also, for instance, in Azure. You could also host it, of course, somewhere else. Just give always these examples fully in a Microsoft context, to do the nature of Blazor and Visual Studio. Right. For the static files, you could, for instance, just use the CDN. It's the most efficient one, also from budget perspective, really good. And for your feed service, just place it maybe on an AKS, a Kubernetes service, and don't worry about scalability there too. So that being said, your pilots, they may be any kind of pilots. They may contain, I don't know, React, Angular, Vue, or be a Blazor pilot. App shell development, well, actually, I don't want to go into this now. I would want to look into the pilot directly, so the microfrontend, but the application shell, in a nutshell, is due to the, the way that it's set up a little bit more complicated with Blazor, actually. Because even though this whole thing, let's say, is pretty much independent of Blazor, I mean, you can create, just using now Pirate as a framework, an application shell that just says, okay, I also want to have a Blazor integration. So that means you use a plugin called Pirate Blazor. And that one always works against the shared assemblies from a Blazor application. And it needs to get them from NuGet. So you get all this branch there that has the Pirate Blazor core NuGet package, and has already a touch point with C#, therefore .NET. And then in your, let's say, pilot, in your microfrontend, you have pretty much the ability of touching any kind of dependency. So you could bring in some more JavaScript stuff from, let's say, NPM, or write it yourself. And of course, you bring in your Blazor code together with maybe some other dependencies from NuGet. And you usually work against the Pirate Blazor utils. All right, so that being said, for the grand finale, let's have a very brief look on the pilot development with Blazor. Let's open this up. And when you start it, we are back at our counter. And the nice thing is, I mean, that's, as you remember, just this library that we started with, right? So lib-a, we just call it. And it's pretty much the same thing, except there are a few differences. So here we have an attribute as mentioned, and we just say, what is the name of this component in our micro front-end world. And we just call it counter here. So we give it the name counter. And that's about it. So there's nothing more to know about this thing. It's a standard Blazor counter. So I think the original example was also not changed here. We may have a counter menu too. So here we expose it as counter minus menu, and we have just an anchor element that we use. And we go to the route / counter. Right. And then we have a module. It doesn't do anything, but it could define more things for instance, dependency injection. And that's about it. So what we can do then is, let me go to the right folder. Let me start that. And let me also show maybe in the meantime the other perspective, because as I said, Blazor is only, let's say, one thing that can be in there. We actually have a JavaScript library for this. And what this one brings in is a setup function where we define all the different areas that should be connected. So here we say, for instance, we connect a tile, and that's just React code here, for instance. But we also register menu and we register page. And in both cases, we are referring our Blazor component that we use. So here we're referring to counter menu, and here we are referring to counter. So the counter page, we refer to counter, and in our menu, we will add the counter menu. And then, hopefully this is done. We can actually open the local host, and we are here at a single page application where we have also counter on top. This is our menu, and this is a Blazor component. And if we go in here, suddenly we have a Blazor page. But the whole thing here is driven by React. And so Blazor is only, let's say, one part of it. And as you can see, that works. And to show you another nice feature, counter came in a little bit later, because this thing is lazy loaded only when it's required, but the whole application is already there, right? So this should just show you, that indeed we got this advantage that Blazor does now need to block the whole rendering, and we can have whatever fast framework we want to. All right. Cool. Now, can you contribute to this? Can you use it? Yeah, sure. Just start Pyrel, have a look at it, especially in the area of, let's say, debugging. I mean, in general, it's quite solved, but especially for, let's say, Pyrel Blazor, that is still challenging. More convenience on top. So this is one of the reasons why we haven't fully published that, but all the code is already out there on GitHub. And things like templating and especially reverse tree shaking are things that can always be improved. So reverse tree shaking refers to this thing that Blazor usually does, is to remove things that you don't need to use. And that's a good thing, and you want to preserve that for microfrontends too. But if someone then uses that's another microfrontend, they need to bring in satellite assemblies with, let's say, the additional code, the diff code, to actually get that working. Right. To conclude, we started with the general microfrontend architecture, from a pure one to how you could do it. Then we went on and derived an architecture for distributed Blazor, all the different steps in either staying only C# or to have the JavaScript on top of it. And then in the end, we've seen just briefly how now a framework for modular web apps looks like, and how Blazor may even be used in such a mode here. As you saw, it just offers possibilities and always tries to have loose coupling, let's say, there as a primary driver. That being said, I'm now here to answer questions. If there are any, follow the conference. It's awesome. And thank you for your attention. And if there are no questions, I mean, I don't see, there. Yeah, the code, yes, code is out there. I think it's on GitHub already. I will place the link in my Twitter profile, so just watch out for it. Like a few minutes after the session, I will tweet that. Yeah. Otherwise, you can also reach us very easily, for instance, in the Pyral GitHub chat. I'm very active there. You'll find the address for the chat in our documentation, or just go to the Pyral repository on GitHub. So it's called Pyral. And yeah, I will also place the link in the QA section of Teams. So if there are no more questions, I would say let's leave it like that. Again, you can always reach me asynchronously, very easily. And I wish you all a nice conference, great day, enjoy your weekend, and have a great time. Thanks.